All right, it doesn't sound like calculus went great for a lot of people. So we're gonna go over most of your homework. So that's all we're gonna do today is we're just gonna go over homework. So today your work is watch this video, make sure you understand what's going on. That's it, that's your homework. The first thing was there was some questions in number 1 in the matching. So I wanna very quickly, emphasis on the quickly, I want to very quickly go over just those ones, and then we're going to move on. Nobody asked me about number 2, but I'm going to graph it anyway because I want you to make sure that you have your answer right. And then 3 and 4 seem to be a problem. So that's pretty much all the homework. So number 1D, remember, this is a matching question. Said 1 over x minus 2 squared. So again, I'm looking for which graph on page 371 gives an accurate picture for this. So x minus 2 squared. So I know that x is equal to 2 has to be an asymptote. So at 2, I know that has to be an asymptote. I also know that there would be a horizontal asymptote where y is equal to 0. Because if I expanded that out, that would be x squared minus 4x plus 4. So the degree on the bottom is bigger than the degree on the top. So there automatically is 1 at 0. But remember that just because there's a horizontal asymptote, that means that at the extreme ends, the graph can't cross that horizontal asymptote. But it could potentially cross that graph in the middle somewhere. That may or may not come into play on this one. I don't actually know. Again, I don't look at the answers before I do these, so I don't honestly know. Just a sec, I'm looking for Harriet. Hun, can you look and see if my calculator's down by the couch? So, I already know that there's an asymptote there and an asymptote there. Harriet showed up. Welcome to the comedy channel. All right, so she's scuffed now. So if I'm doing this, I'm gonna check a value very, very close to 2 on either side. So I'm gonna check 1.9. If I do 1.9 minus 2 and square it, and I do 1 divided by that, I get positive 100, meaning it's very high. Now, if I put 0 in as my x value, and I'm doing this for a reason. If I put 0 in as my x value, 0 minus 2 is negative 2 squared is 4th. I actually get 1/4. So it's still above this x-axis. And so my guess is it's going to do this. And on the other side of 2, so let's say 2.1, I'm also going to get positive 100, meaning it's going up here. So, do I have a graph that looks like that? To me, it looks like graph number 5. So D is graph number 5. That's what I would say. They should tell you at the back of the book, and again, I'm just going to double check just so that I'm not lying to you. 6.6, 1D, actually they say is 9. Let me look and see why. Oh, because I'm wrong. I don't know why I said 5. I've got them both up and number 5 doesn't look like that at all. Let me look. Yeah, that's better. Number 9. Duh. I don't really know what I was doing. Sorry. I've been outside all day. I have no brain at this point. All right. That picture looks like the picture on number 9. So, that's D, F. F says, looking for it, x squared over x minus 2. So again, I know that I have a vertical asymptote at 2. On this one, the degree on the top is exactly 1 more than the bottom. So that means that I'm actually going to do, I'm going to divide the bottom into the top. And so how do I turn x into x squared? I multiply it by x, which gives me x squared minus 2x. I'm going to subtract, and so I'm going to end up with a positive 2x as my remainder. So y is equal to x is my oblique. So it's going straight through here. Now I haven't graphed anything, but I'm going to check and see whether or not I have something that looks like that. Let me see. I have one at 2, but that's not that asymptote. I have another one at 2, but that's not that asymptote. It's only one asymptote. Okay, so I have not figured this out fully yet, obviously. I'm thinking. Hold on. Oh, wait, because I wasn't done this. That's what the problem is. See, I told you. Not on the ball yet. My brain is not turned on to calculus yet. Hold on. It will. So how do I turn x into 2x? Right, because I got 2x here. I multiply it by 2, which is going to give me 2 times x is 2x minus 4. So now I will subtract and I will end up with positive 4. There's my remainder. So x plus 2. So actually my y-intercept should be at 1, 2. So it should actually go like this. So now let me look and see if I have that. And I do. It's number 11. It's number 11. So I would say 11. And at the back of the book, they would say, I hope they would say the same thing I would. F is 11. Yes, they do. Thank goodness. All right. So when I noticed that my graph did not match any of the graphs on that page, I went back and went, what did I do wrong here? That's what I did, because that meant I must have done something wrong. Okay. So I did F, H. H says x over x minus 2 squared. So again, the only vertical asymptote would be 2, because 2 take away 2 would be 0. So I got one of those. Horizontal asymptote, the degree on the bottom is going to be 2, the degree on the top is 1. So therefore, horizontal asymptote, yay. So now I'm going to do a quick table of values, and I'm going to do 1.9 and 2.1 for sure. If I do 1.9 minus 2 squared, and then 1.9 divided by my answer, that's 190, so way up here. And if I do 2.1, 2.1 minus 2 squared, and then 2.1 divided by my answer, I get 210. So also way up. Now, that looks very much like number 9. However, I've already used number 9. It can't be that one. The other one that looks very much like number 9 is number 1. The difference in number 1 is in number 1, it actually crosses this asymptote. And the place where it looks like it kind of crosses that asymptote is when my x is 0. And I'm just getting that off the graph, right? I'm kind of working backwards here. It's called reverse engineering. If I put 0 in, I have 0 take away 2 is negative 2, squared is 4, and 0 divided by 4 is actually 0. It actually gives me an answer. It doesn't come up as like undefined. It actually gives me an answer of 0, which means this is actually going to cross and then have to not do that. So that means that H must be number 1. It's the only other option available to me that looks like that. And again, double checking, H is 1. Yay me. J. J says x squared over x squared minus 4. So already I know that there are 2 vertical asymptotes this time, because 2 squared would be 4, take away 4 would be 0. But negative 2 squared would be 4, take away 4 would also be 0. So this time I've got 2 vertical asymptotes. And if I look at my pictures over on page 371, there are several options there for that scenario. Now, also the degree on the top, the degree on the bottom are the same. So I take the leading coefficients, 1 over 1. So at 1, there is a horizontal asymptote. Now that may knock some out for me. Yep, it looks like it knocks out number 3. It knocks out number 4. And yeah, it looks like the only one it doesn't knock out is number 2, because the only one to have 2 vertical asymptotes, one at 2 and one at negative 2, and a horizontal asymptote at 1, the only one I see that has that is actually graph number 2. So even though I didn't bother to graph anything, I didn't actually need to, because only one had the criteria that I needed just for the asymptotes alone. And again, double checking just to be sure, but J says number 2. L should have been, well, you only have one option left, right? If you did them in order, by the time you get to L, you should only have one option left. But because we've skipped a bunch, we actually have some other options. So let's look at it. X cubed over x squared minus 4. So this time it's x cubed over x squared minus 4. So again, we haven't changed the bottom, so I still have a vertical asymptote at 2 and one at negative 2. However, this time the degree on the top is one more than the degree on the bottom, which means I have an oblique asymptote. So if I look on my graph, again, I don't even need to figure out what it is, because there's only one graph on that whole page that has 2 vertical asymptotes, one at 2 and one at negative 2, and has an oblique asymptote, and that is number 12. So I don't even need to know where that oblique asymptote is. Doesn't matter, because there's only one of them that fits the criteria, and that is number 12. And again, double checking, yes, L is number 12. So you didn't have to be able to graph all of them. That really wasn't the point. The point was, could you figure out enough information to pick which one it should be? And by process of elimination, I could. All right, number 2, nobody actually asked me for number 2. However, I want you to be sure that your graph is correct for number 2, because I'm sure the answer is not at the back of the book for it. So I'm going to do it just so that you know you have it right. Jessica was sketching the graph of a function but shouldn't have time to finish it. She lost some of her notes. So the domain of the function is the set of all real numbers except x is 1 and -1. So already that's telling me that at 1 there's a vertical asymptote, and at -1 there's a vertical asymptote. Now it says the limit as x approaches 1 from the right-hand side is -infinity. So as we approach 1, yes, as we approach 1 from the right-hand side, it's -infinity, so it's going down. As we approach 1 from the left-hand side, we have +infinity. Okay. As we approach -1 from the left-hand side, it's -infinity. And as we approach -1 from the right-hand side, it's +infinity. Okay, so I haven't filled in the middle of anything yet, but I at least have what's going on close to the vertical asymptotes. Now it says the limit as x approaches +infinity. So as we get out here, f at x is less than 0 as x approaches infinity. So here's 0 right here, meaning there must be a horizontal asymptote there. So it's less than 0 as it approaches infinity. They say the same thing about -infinity. As we approach -infinity, the graph is less than 0. It is below the 0 line. The y-intercept is 2, and there are no x-intercepts. That's what your graph should look like. And I did it just by following the clues that they gave me. All right, I just did what they said. All right. Number 3. Number 3, you had to do A, B, and F, and it said sketch each function. So I am going to do each one simply because you need to know whether your graph is right or not. So even if you think you got it, you can at least check your answers. And again, if you already know, listen, I know this question, you can just fast forward through it, right? It's the beauty of me as a video. So 3a is x cubed plus x. All right, so this is going to be a linear graph. It's not a fraction. So we're not thinking about asymptotes at all. Yay. So we need to think about where is it increasing, where is it decreasing. So we're going to do the first derivative, which is going to give me 3x squared plus 1. So I'm going to make that equal to 0. So I'm going to move this over here, and I'm going to have -1 is equal to 3x squared. And then divide by 3, so x squared is -1/3. So I'm going to take the square root of both sides, but here's the trick. I can't take the square root of a negative number, right? I can't do that. So that means that there is no local max, local min. There is nowhere where it changes direction. It is always either increasing or decreasing. And how do I know which it's doing? Pick any number you want. Doesn't matter the number because there is no before or after. So pick any number you want, put it in here and see if you get a positive or a negative answer. So if I pick 0, this would be 0 plus 1. I would get a positive answer. So it doesn't matter what number I put in there. My answer is always positive, which means the graph is always increasing. It's always going up. There's no local maximums or local minimums. But are there any points of inflection where it changes from concave one way to the other? To figure that out, I do the second derivative, which would be 6x. I'm going to make that equal to 0, and so x would be 0. So that's a testing point. I'm going to check if I pick a number less than 0, I'm going to get a negative answer when I put it in here, like negative 1. 6 times negative 1, negative 6, so it's concave down. After 0, so positive 1, I would get a positive answer, so concave up. So I have a point of inflection when my x is 0, but I need to know what my y would be. So I put my 0 back up here into the y equals, so 0 cubed is 0 plus 0 is still 0. So I have a point of inflection at 0 and 0. So before 0, it's concave down. After 0, it's concave up. But the whole time, the graph from left to right is headed upward. It's always increasing. That is 3A. 3B looks longer. I hope it's not, but it could be. 3b is 2x cubed plus 15x squared minus 36x. All right. So we are going to go through the same process. Again, this isn't a fraction. Therefore, we don't have to worry about asymptotes. This will be a linear graph, straight line, no breaks. So it's just, is it going up? Is it going down? Where is it doing those things? Any local maximums, local minimums, any points of inflection, any of those things. So first derivative would be 6x squared plus 30x minus 36. I'm going to make that equal to 0. Now myself, I would see that 6 is a common factor. I would take it out so that hopefully I can factor this. If you suck at factoring, do the quadratic equation. I don't care which. For me, factoring takes a significant less amount of time. And so x could equal 3 or 2. Oh wait, that can't be right. Nope, that's not right. I did not factor that right. I rushed through it. That would give me negative 5, and I need a positive 5. And it would give me a positive 6, and I need a negative 6. So let me actually just change that. If I did positive 6 and negative 1, positive 6 times negative 1 is negative 6, and 6 take away 1 is 5. So that's better. So x could be negative 6, or x could be 1, which is going to be easier to do. So negative 6 and 1. So I'm going to figure out increasing and decreasing by picking a number less than 6, negative 10, putting it back into the derivative. Do not put it back up here. Put it into your derivative. So if I do negative 10 squared is 100, so that's 600. That would be 600 minus 300 minus 36. I'm going to get a positive answer. I don't even care what the answer is. It doesn't matter. It only matters is it positive or negative. So therefore, it's increasing before negative 6. Between negative 6 and 1, well, obviously I'm going to pick 0, which is going to give me a negative answer, so it's decreasing. That means I have a local max where x is negative 6, sorry. So I'm going to take that negative 6, I'm going to put it back in here to figure out my y. So, negative 6 cubed times 2 plus 15. Negative 6 squared is 36, so times 36 minus, so minus 36 times negative 6. I get, whew, that is a max. I get 324. That is a maximum. Now I need to pick a number bigger than 1. So 2, 10, I don't care. I'm going to do 10 just because I can do 10s really quickly in my head. 10 squared would be 100 times 6 would be 600. And then that would be plus 300. So now I'm up to like 900 minus 36. Definitely a positive. So there's a minimum there, right? Because it's down here. So I have a local minimum when x is 1. So again, I need a y value, so I'm going to put it back up into here. So this would be 2 plus 15, which would be 17, and 17 minus 36 would be negative 19. So that's my minimum. So now I have figured out the shape of the graph. It's going to do that. And I need any inflection points. So I'm going to do the second derivative here. So this would be 12x plus 30. I'm going to make it equal to 0. So negative 30 equals 12x. So x is negative 30 over 12. If you like it better as a decimal, I don't care. It's negative 2.5. Unfortunately, it's a decimal. That sucks. But I'm going to pick a number less than negative 2.5. Anything you want. Let's say negative 5. 12 times negative 5 is negative 60. Plus 30 is going to be a negative answer, so it's concave down. After negative 2.5, say 0. I will get a positive answer, so concave up. So it changes, so I do have an inflection point at negative 2.5. Unfortunately, I have to then take that and figure out my y value. So negative 2.5 cubed times 2 plus 15 times 2.5 squared minus 36 times negative 2.5. All right, I get 152 and a half, 152.5. I'm now ready to graph this. Now, obviously, I'm not going to have 324 squares. This is a sketch. So just make it reasonable, okay? So negative 6, 1, 2, 3, 4, 5, 6, and 324. Let's say that is 324. Again, we're just sketching. Don't get hung up on the, oh my goodness, how do I represent 324? You don't, all right? So before negative 6, it's increasing. After negative 6, it's going to start to go down. It's going to start to decrease. At negative 2.5, 1, 2.5, and 152. Well, 150 is like half of 300. So it's about halfway. About halfway between that. It changes from being concave down to being concave up. And again, nothing dramatic is going to happen there. We could talk about intercepts as well, which I forgot to talk about in the last one, but that's okay. The big intercept I would find is if x is 0, what is y? Because that one's easy to find. If I put 0 in here, 0, 0, 0, my y is going to be 0. The one that's harder to find is if you make your y 0, what is your x? And with something like this, I probably wouldn't even bother. But 0 and 0 is going to be 1, and then it's going to have a local minimum at 1 and negative 19. Well, if 320, negative 19 is really, relatively speaking, going to be like here, and then it's going to turn and come back up. So there really are 3 x-intercepts. One of them is 0 and 0. The other 2 x-intercepts would have been found this way. The other two, where is this and where is this exactly, would have been found by making my y 0 and having 2x cubed plus 15x squared minus 36x. What I would have done with that is I would have taken my x out as a common factor and had 2x squared plus 15x minus 36, so that x is equal to 0, but this trinomial is equal to 0. Now, I'm probably not going to be able to factor that very quickly in my head. Maybe I can, like maybe I can do 2x and x, and I don't know, it would be 6 and 6, which would make 12 and 6, which wouldn't make 15, so that wouldn't work. So 5, no, 4, 9 times 4. If I did 9 and 4, that would be 18 and 4, that wouldn't work. So if I can't factor it right away, I would do the quadratic equation. So negative b would be negative 15 plus or minus the square root of 15 squared minus 4 times 2 times negative 36 all over 2 times 2. If you don't do this, it's not the end of the world, because we're just sketching. This is a lot of work. If you start doing it and you find, oh my word, I have to do all this, don't bother to find it. We found the y-intercept at 0 and 0. We know there are two other ones, so if you don't find it, again, not the end of the world. So if I was to continue this, I would do 15 squared plus 4 times 2 times 36, and then I would do the square root of that, which isn't going to work out nicely, minus 15 divided by 4. Yeah, see, like it works out to be 1.9. And that's not really something that I'm going to figure out, right? So don't worry about that so much. So it crossed the 0 line where x was 1.9, and I could have figured out the second one. I'm not so concerned about that as you getting your local max, your local min, your points of inflection. Really finding the y-intercept is really easy because you just make your x 0. So that was easy to find. The other two, you'll get them in approximately the right place just by sketching the graph anyway, so it's not that important. 3f. Says 2 minus 15x, oh, I hate it when they put it in this order, plus 9x squared minus x cubed. Well, I hate it when they do that, so I would probably reverse it. Now, again, let's at least find the x-intercept while we're here. If I make my x 0, this is 0, this is 0, this is 0, I'm going to get 2. So I already know that it has a y-intercept of 0 and 2. Now, could we figure out x-intercepts? Maybe. I would make my y 0, and I would do this. The thing about this is there's no common factor to take out, and so to factor this, I'd have to find all the factors of 2, put them in, see which one equals 0. I'd have to do synthetic division. It would get very, very long. I'm not going to bother to do that. You don't need to bother to do that. I'm not asking that of you, okay? So I'm not going to bother to find the x-intercepts. Likely, it will be easy to tell when I do it anyway, an approximate of where they are. So I'm going to find where is it increasing and where is it decreasing. I'm going to find my first derivative. Now again, I don't like it in this order. So I'm actually going to do the derivative backwards. I'm going to do the derivative of this, then this, then this, then this, because I like it better that way. So the derivative of negative x cubed is negative 3x squared. The derivative of 9x squared is plus 18x. The derivative of negative 15x is minus 15. And then the 2 is 0. I'm going to make this equal to 0. Personally, I would take a negative 3 out as a common factor, leaving me with x squared, not plus 6x, minus 6x. If I take negative 3 out of there, plus 5. So that factors, I hope, to x minus 5 and x minus 1. Negative 5 minus 1 is negative 6, and negative 5 times negative 1 is positive 5. So that means x is either equal to 5 or 1. So, picking a number before 1, like 0, putting it back into here would be 0 plus 0 minus 15. I'd have a negative, so it is decreasing. Between 1 and 5, like 2. 2 squared would be 4, times negative 3 would be negative 12. Plus 18 times 2, which is 36, and then minus 15, I get a positive 9. So it's increasing, meaning I have a local minimum when my x is 1. So I'm going to put that back into here and see what I get. 2, that would be minus 15, so that would be negative 13. That would be plus 9, and then minus 1 gives me negative 5. So I have a local minimum at negative 5. Now I need to pick a number bigger than 5, put it back in here and see what I get. Any number bigger than 5, I'm going to choose 10. 10 squared is 100, so that's negative 300 plus 180 minus 15. It's going to give me a negative, so it's going to decrease. So I have a local maximum when x is 5. So I'm going to put that in here. So 2 minus 15 times 5 plus 9 times 25, because 5 squared is 25, minus 5 cubed gives me a positive 27. So that's my local maximum. So now I need to talk about inflection points. So second derivative would be negative 6x plus 18. I'm going to make that equal to 0. So negative 18 is negative 6x. So x would be 3. So before 3, so say 0, this would be positive, so it's concave up. After 3, so say 10, that would be negative 60 plus 18, that would be negative, so concave down. So I have an inflection point when my x is 3. So again, I'm going to need to put that in here. So 2 minus 15 times 3, which is 45, plus 3 squared is 9. 9 times 9 is 81, minus 3 cubed, which is 27. So I get 11. So I have a y-intercept at 0 and 1, 2. I have a local minimum at 1 and negative 5, which means if that's a local minimum, it means it's decreasing before that, right? Decreasing before that. Then it changes to increasing. And I have a local max at 5, 1, 2, 3, 4, 5, and 27. So there's 27, all right? And in between that, at 3 and 11, that's my point of inflection. That's where it changes from being concave up to starting its turn to being concave down, because that's a local max. And then it will head down from there. So again, we didn't bother to find the 3 x-intercepts because it was going to be too difficult to find them, but we kind of get an idea of where they would be anyway. All right, so that's number 3, where there are no asymptotes and it's a linear graph. We find the first derivative, the second derivative, we find intercepts if it's convenient and easy to do so, and then we just give a picture of the graph. Number 4. We're almost done. Yay! Number 4, we did A, D, and E, or you were supposed to do A, D, and E. So A is x minus 2 over x plus 2. So we have a vertical asymptote for this one. The vertical asymptote should be at -2. Because the degree on the top and the degree on the bottom are the same, that would be 1 over 1. We have a horizontal asymptote where y is equal to 1. I'm going to talk about intercepts here as well. If my x is 0, what's my y? If my x is 0, I have 0 take away 2, which would be -2, and I have 0 plus 2, which would be +2, which gives me -1. So at 0, I have a point at -1. Again, I could make my y 0. So if I do 0 is x minus 2 over x plus 2, relatively easy to solve for. I'll multiply this side by x plus 2 so that they cancel. That means I multiply this side by x plus 2, so I have 0 is equal to x minus 2, so x would equal 2. So I have a point at 2 and 0. So 1, 2, and 0. So I haven't even done a table of values or anything to figure out as it approaches the asymptote what's it doing, but by finding my intercepts, at least on this side of the asymptote, this is headed this way, but it's not going to be able to cross, and this is headed downward, but it's not going to be able to cross. So I already know that that side looks like that. The only question is, does it go down on this side or does it go up? Now I already have an idea because there are no intercepts over here. It's not crossing this line over here. So my guess is it's going to be up in this section, but I'm going to double check it just to be sure. I'm going to check, what if my x is -2.1? What if it's on this side of the asymptote? Because all my intercepts happened on this side of the vertical asymptote, so I need some information about over here. Not a lot, but a little bit. So if I do -2.1, why am I using my finger? If I do -2.1, -2.1 minus 2 is -4.1. -2.1 plus 2 is -0.1. If I divide those two, I'm going to get +41, meaning on this side it's way up here, meaning as it comes down it can't cross that asymptote, and therefore that is what my graph looks like. So that is for A. For D, x over x squared minus 4. So for this one, again, thinking about vertical asymptotes, horizontal asymptotes, maybe even oblique asymptotes. In terms of vertical asymptotes, it's x squared minus 4, which means my x could be 2 or -2. So I have 2 vertical asymptotes. The degree on the bottom is bigger than the degree on the top, therefore there is a horizontal asymptote at 0. Intercepts. If my x is 0, what is my y? Well, 0 divided by -4 would be 0. Remember, just because there's a horizontal asymptote doesn't mean that in the middle the graph cannot touch, cross, whatever the horizontal asymptote. It is at the extreme ends where the asymptoteness of the line kind of kicks in and it can't cross. What if my y was 0? What would my x be? So again, I would do 0 is equal to x over x squared minus 4. So I'd multiply this side by x squared minus 4, so that cancels. I'd multiply this side by x squared minus 4. So I have 0 is equal to x. So this is the only place where it crosses, touches, does anything to any of the axes. 0 and 0 is my only place. So now I'm going to do a quick table of values, but that quick table of values is going to just be surrounding these vertical asymptotes. So I'm going to do -2.1, I'm going to do -1.9, I'm going to do +1.9, and I'm going to do +2.1. If I do -2.1, I have -2.1 and -2.1 squared minus 4. I end up with -2.1 divided by 0.41, which gives me -5.12. So not a huge negative number, but still a negative number. So it is headed downward, which means as it goes this way, it's going to head up, but can't cross that. -1.9 would be, again, I'm just going to put this in my calculator, 1.9 squared minus 4. So -1.9 divided by my answer, I get +4.87. So on this side, I'm headed up. +1.9, I would get 1.9 squared minus 4, and 1.9 divided by my answer, I actually get -4.87. So it's actually headed down this way. And then for 2.1, I would do 2.1 squared minus 4, and I would do 2.1 divided by my answer, and I get like +5.12. So I get this positive thing. So as it comes down, it's here. Here in the middle is where people get kind of confused. On this side, it's going up. On this side, it's going down. And we have this intercept here. So actually what it's going to do, something like that. Again, it can cross a horizontal asymptote in the middle. It is at the extreme ends that it cannot. So that's what your graph should look like for 4D. 4E is 3x over x squared plus 1. All right. Very similar in comparison to the one we just did. So in terms of vertical asymptotes would be 1 and, nope. In terms of vertical asymptotes, x squared plus 1 would equal 0. So x squared would equal -1. You can't take the square root of a negative number. So guess what? There is no vertical asymptote, because there is nothing that would put 0 on the bottom of a fraction for 4e. There just isn't one. I think maybe I meant to give you 4C, but I'm not sure. But anyway, we'll keep going with this. So there is no vertical asymptote. Horizontally, there is one because the degree on the bottom is bigger than the degree on the top. There's automatically one at 0. In terms of intercepts, if my x is 0, this would be 0 divided by 1, which would be 0. So this is another one where there actually is a 0 and 0 point. And if I make my y 0, I would have 3x over x squared plus 1, multiply this side by x squared plus 1, multiply this side by x squared plus 1, I'd have 0 is 3x. X would still be 0. So the only place it crosses any axis is at 0 and 0. For this one, I can't do a table of values in terms of a vertical asymptote. So what I would do with this one is I might actually do a quick table of values, but my table of values is going to be kind of weird. I'm going to pick, remember that it can cross a horizontal asymptote, but not at extreme ends. So I'm going to pick something at an extreme end. So negative 100. And I'm going to pick something at an extreme end over here, so positive 100. We already know what's happening at 0, so let's pick something like negative 1 and positive 1, so something just on either side of this, and maybe negative 10 and positive 10, so just a little bit further on. So if I do this, if I do negative 100, that's negative 300 on the top, and negative 100 squared plus 1 is a very large number. So negative 300 divided by my answer, I get like negative 0.03. So at the extreme end, at negative 100, it is just below this horizontal asymptote. At negative 10, that would be negative 30, and negative 10 squared is 100, plus 1 is 101, so divided by 101, it's negative 0.29. So at negative 10, it's a little bit further down, right? Because this is at 0.03, so really close. This is at 0.29, so still close to the asymptote, but not as close. At negative 1, it would be negative 3, and negative 1 squared is 1, plus 1 is 2, so it would be negative 3 over 2, which would be negative 1.5. So it actually does this, right? It comes down a little bit and then it starts heading back up. And I would check the same thing on the other side. I forgot to put the positive 1 here. If I do 1, 3 times 1 is 3 over 2, it would be positive 1.5. So positive 1.5 at 1. At 10, that would be 30 divided by 101, which would be 0.29. If I do 100, it's going to be positive 0.03. So it does a very similar thing where it comes up a little bit and then starts heading down. That is actually what 4E would look like. That one was tough because when there's no vertical asymptote, people don't know what to do. Find the intercept, which in our case happened to be 0 and 0, and then do something close to either side of that intercept and do something at the extreme ends of the horizontal asymptote. So like positive infinity and negative infinity. So I did like negative 100 and positive 100. You might not even have to use an actual value. Some of you could just like negative infinity. Well, I would have a negative over a positive, which would give me, like some of you can do that in your head. If you didn't follow what I just said, don't worry about it. you can do a quick table of values, but you shouldn't have to do a million numbers. Like I did a few, and I actually did more than I would normally do. Like I wanted to show you what it looked like. I wouldn't bother to do that many. I wouldn't have done the -10 and the +10 normally, just for sketching it. So hopefully that helped. So your only homework was to watch this video and kind of go through your homework and make sure you can follow that. Maybe, yeah, that's pretty much it, I think. So tomorrow, tomorrow. Okay, that's all we're doing for section 6.6. There are other examples, but they're kind of nuts. Like they're kind of crazy examples, so we don't bother to do them. So we're done section 6.6. That is it for what we're doing with section 6.6. Tomorrow, I am going to start with the word problems. All right, there are 2 sections of word problems. We will not be doing all of the examples in both sections. So just be aware, we only have a few days left. I haven't done my lesson planning yet. I should have by now, but I have not. Probably if we do Tuesday, we do one section, Wednesday we do another, Thursday, probably at least Monday of next week. Okay, so that would be the earliest that we would do it. And again, we'll see how things progress. But at the earliest would be Monday of next week. All right, so hopefully that helped. If you still have questions, please tell me that. Otherwise, I'm going to move on into the word problem section. All right, so we'll talk to you again. Bye.